Welcome, this is Colleen Doak from St. Ambrose University, and if you've been following the previous presentations, this is building up on the causal pies that we talked about in some of the earlier presentations in the early part of the term, and using those to explain the concept of effect modification. And I'm going to integrate those causal pies with the formula that Rothman gives for measuring effect modification on an additive scale. I'm going to start with the concepts. And the concepts go back to these causal pies we talked about in the beginning of the term in epidemiology, and that is that there are different ways of visually representing the factors that combine together to cause a disease, in this case cardiovascular disease. So the left pie is representing the concept that people who smoke may get cardiovascular disease because of the smoking. The second pie represents all those people who get cardiovascular disease because of having a high-fat diet, and the third pie represents that set of people who would not have gotten the disease if they just smoked or just had a high-fat diet, but they have the risk because they have a combination of smoking and the high-fat diet together. So when we're testing for interaction, the question we're really asking is, does that third causal pie actually exist? And so when Rothman gives this formula of additive interaction, he's saying, essentially, if you add up the first pie and that second pie, and the people who smoke and have a high-fat diet have all their risks that can be explained by the first and the second pie, then that third pie doesn't exist. But if you can show that people who smoke and have a high-fat diet have more risk or an extra risk than they would have just from the smoking and the high-fat diet, then that third pie makes sense. So that third pie appears in your data and you can measure it. Now, how do we do that? Essentially, what we're talking about is that the left causal pie reflects the risk of CVD relating to just smoking. The second one is the causal pie that relates to just having a high-fat diet. And that third pie reflects a scenario that some people will get the cardiovascular disease only if they both smoke and also have a high-fat diet. So these concepts of looking at just the exposure, just the effect modifier, or both together are the basis for the formulas that he writes out when he gives the formulas on page 204 and 205. So in those formulas on page 204, 205, he represents the exposure and effect modifier separately as A and B. So although I've put the two together on the right side in his formula, he's put the risk related to both together on the left side and compared them to the risk of just one plus also just the other. So you can actually mathematically see whether the risk of both together is the same, greater than, or less than the risk of just the exposure and risk of just the high-fat diet, the effect modifier. So now I'm going to throw in the concept that some people are getting the disease, they're getting cardiovascular disease, even though they don't smoke and they don't have a high-fat diet. And those are the people we're comparing to when we create our risk ratios. And that becomes important because we're saying, well, it's not just smoking, it's not just the high-fat diet or the combination of two, but we're also looking for an excess risk in comparison to those people who don't have either one of these risk factors. And without that unknown causal pie, or without comparing them to the non-smokers who don't have a high-fat diet, we can't really have a comparison group where we can understand what is the risk just related to smoking, what is the risk just related to the high-fat diet, and is that different from the risk when they both occur together. So when you line up these pies, and I'm just numbering them 1, 2, 3, 4 to clarify that pie 2, that's the risk related to just smoking, becomes the risk related to just smoking when it's compared to 1. So we can see if we can compare the smokers to the non-smokers who don't have a high-fat diet, so that would be causal pi 1, we can get a sense of what is the risk just related to the smoking. Similarly, the next step is what is the risk of just having that high-fat diet? And again, we need to have the same comparison group in order to say the risk of the high-fat diet is being compared to the non-smokers who don't have a high-fat diet. So that we can say that 2 is we're looking for just the risk of smoking, 3 is we're looking for just the risk of the high-fat diet. So we're comparing 3 to 1 in our risk ratio. So mathematically, we're getting at the risk ratio of the high-fat diet compared to those who are non-smokers without the high-fat diet. And ultimately, the purpose of this is to compare the effects of just, or the risk of just smoking, plus the risk of the high-fat diet to those people who both smoke and have a high-fat diet. So in other words, the risks of the two together. And the question is, in that fourth pi, what is the risk of both together? And again, we have to compare that to the same reference group we used for causal pi 2 and causal pi 3. So we're talking about the smokers who have a high-fat diet, and we're looking at their risk in comparison to those who are non-smokers and who don't have a high-fat diet. So that's how we look at the risk of the two together. So with Rothman's formula, ultimately what we're looking for is the excess risk of smoking. So that's going to be a relative risk of the smokers divided by the risk. In other words, the relative risk, the comparison group is going to be the unknown, the non-smokers, non-high-fat diet. And we're going to add to that the excess risk of the high-fat diet group. And we're going to see whether or not that is equal to, less than, or greater than the excess risk of smoking and having a high-fat diet together. Now, in the formula, you're going to see a couple of things that aren't completely reflected in these slides, and one is that we're talking in terms of a relative risk. So all three of these risk groups have to be compared to that same comparison. And the second thing is there is a -1 in each of these equations, and that allows us to talk in terms of excess risk. Additionally, the question is whether there is an excess risk, so whether there's a greater than or less than or even equal to, when you're looking at the additivity of the effect modifier, the exposure, and the effect modifier together, and you're comparing it to the results of people who have both of those risk factors, the effect modifier and the exposure. So how do you look at excess risk related to smoking? Essentially what you're looking at is you're taking the risks in the smoking group and you're subtracting it from the non-smoking, non-high-fat diet group. That makes it excess risk. So when you think of a relative risk, so you're using your unknown, your non-smoking, non-cardiovascular disease group, both as your denominator, so that's how you get a risk ratio, but you're also using it in your minusing 1 group. And this may seem counterintuitive. Why would you take 1.4? You've already got this comparison group in your denominator of your risk ratio. Why then also subtract out the 1? Well, the 1.4 is the risk ratio. That gives you what is the risk ratio related to smoking. Smokers are 1.4 times more likely to have cardiovascular disease than the non-smoking, non-high-fat diet group. But when we're talking about excess risk, we actually have to take out that 1 from the equation of the relative risk, because that 1 actually means no risk. And let me put this in a different way. So if you want to understand why subtracting the risk ratio of 1 from the relative risk, imagine if the risk ratio for smoking actually were exactly equal to 1. 1 minus 1 is equal to 0. So in other words, if your original risk ratio was 1, you would know already there is no excess risk. So it makes sense to subtract that 1 because excess risk is 0. So essentially, whenever you're doing excess risk, you're looking at a risk ratio and you want to say, what excess risk does this risk ratio represent? Subtracting out that 1 makes it into a concept of excess risk rather than just a risk ratio. Again, so if we're looking at the effect modifier, we're talking about then the high-fat diet in this example. And you have the same comparison group of the non-smoking, non-CVD group. And then you're subtracting out that underlying 1 once again. So your excess risk from smoking originally was that 0.4. Your excess risk for the effect modifier was that 0.7. And adding the two together is 0.4 plus 0.7, which comes to 1.1. So that's the excess risk when you add up the excess risk of smoking and the excess risk of the high-fat diet. So the exposure and the effect modifier, excess risk added together is 1.1. The question is, what about the smokers who have a high-fat diet? Does that result of adding the two risk factors together reflect the reality of the risk in the smokers who have a high-fat diet? And so you can actually measure that. So you see that the excess relative risk of smoking on a high-fat diet is 2.4, and you can subtract out that underlying 1, and the excess risk of both together is 1.4. So if you remember, so the excess risk of both together is 1.4, but when you add the risk of the exposure, the smoking, plus the risk of the high-fat diet, it was 1.1. So when they occur together, the excess risk is 1.4, which is greater than 1.1. So what we have is an amplified risk. The effect modification shows a risk, an excess risk that is greater than additive or amplified. So here I'm going to shift to the question of how are you actually going to test this in your data. So conceptually, the causal pies show you visually what are you looking for. The next slides are going to show you how to actually generate that information on the additive scale. And so the second set of the YouTube video and PowerPoint slides will actually go through with your R output, your 2x2 tables in R, and show you where to pull it from in order to fill in these tables. So once you've listened to this concept and can imagine what it will look like, go to the second YouTube video and that will help you see which place to take your data from in R and how to fill in that table. Okay, I'm going to break this table down for you. What's important to know is that the exposure is 1 or yes if the exposure is present. So that's basically every time you see exposure equals yes, relabel that to bullied before the age of 12 because that's what you're all looking at as your exposure. So that means in the first row, that is looking at the kids who were bullied before the age of 12. In the second row, you're looking at the kids who were bullied before the age of 12. Then the third and fourth rows are the kids who reported that they were not bullied before the age of 12. The difference between these 4 rows has to do with the combination of the exposure and the effect modifier. So that's going to depend on whether you're choosing, for example, urban or rural as your effect modifier, whether it's male, female, or whether it's older or younger. So I'm going to go through this example using the example of urban and rural. So let's say urban is your effect modifier. It means the first row, you're looking for how many urban kids reported having been bullied before the age of 12. What's the total sample size? That's the N1, that's the last column position. And how many of those kids who were urban and bullied before the age of 12 reported being always blue in the past month? So that's your A1 number. So with the A1 and the N1, you have the risk in the kids who were both exposed to bullying before the age of 12 and had the effect modifier of urbanicity. The second row is just measuring the exposure alone. So that's not the urban kids, that's the other group, the no group for the effect modifier. That's the rural kids. So you're going to look for the rural kids who were bullied before the age of 12, and you're going to ask how many of them reported being always blue, and how many of them in total, the N2, how many of them were there. So the B1, B2, B3, B4, you don't need that information. It's just there in case it makes it easier for you to connect between your A1 and N1. So if you're missing your N1, just make sure that you add up the A1, B1 to get your total sample. So that column outcome equals no. You can ignore that if you know what your sample size is for each of these groups. The third row that you see is just measuring only the effect modifier. So that is how many of these kids were just urban, so imagining urban residency as your effect modifier, but who were not exposed to childhood bullying. So that's urban kids who were not exposed to bullying. So look in the urban group who said they weren't bullied and see how many of them reported having been always blue in the past month and how many of them were N3, how many of them were there in total. And the final group is something you're going to use for all of your risk ratios. So here we're looking at just the risks, but the risk ratio is going to require a comparison group, and that is how many of them did not have the exposure and did not have the effect modifier. So you're talking about they were not urban, they were rural. So you're looking at the rural kids who were not bullied. And that's how many of them reported being always blue in the past month, and how many of them in total, N4, were there. So with this information, you fill in A1, A2, A3, A4, and N1, N2, N3, N4, and you have your risks for each of these conditions. Your risk 1-1, which is your exposure, your effect modifier together, your risk of just the exposure, your risk of just the effect modifier, and your risk of neither having the exposure, just the underlying risk, neither having the exposure nor the effect modifier. And so just to remind you in the formula, the excess risk is related to the exposure, and the effect modifier is that concept of a risk ratio of both together. So that first row, the risk 1-1, minus the unknown. So minus that 1. So that's in the formula of risk ratio 1-1 minus the 1. So that reference group, that 1 that you're subtracting, reflects the unknown factors. And so when you're putting this into the formula, your first thing you're looking for, which is on the left side of the formula in Rothman, is the risk ratio of both together minus 1. So that is the risk of the 1-1 condition, that's A1, divided by the N1. And you're taking that and you're dividing it by the risk in the no-no condition. So that's the A4 divided by the N4. So the risk in 1-1 divided by risk in 0-0. And then you're subtracting out the underlying 1. So here I've spelled it out for you, R00 divided by R00, but that's essentially getting rid of the underlying 1 condition. So just going back to the concept of what does it mean when there's no excess risk, that just means that your risk related to both conditions together is 1, is the same as your referent group. So if it were 1 minus 1, it would be 0 excess risk. Or if this were not a risk ratio, and it were just simply risk, then your risk in the joint condition, if it's identical to the risk where neither the exposure or the effect modifier are present, you would still get 0 excess risk. You see excess risk when the risk of the joint effects is greater than the referent group. So in other words, that's representing the causal pi on the left, subtracting out that underlying 1. So when it's greater than 0, we're talking about excess risk. Again, so we start with the concept of we're looking at the excess risk related to the effect modifier, and the exposure together, so the joint risks. But then we also need to calculate the excess risk just related to the exposure. And then we need to compare that to the risk just related to the effect modifier, add those two up and compare them to the risks related to both together. So here we move into looking at the risk of just the exposure. So that means looking at, in that original table, the risk related to the exposure. So that is the second row, the A2 divided by N2. And we're comparing that to the neither condition, the R00. So remember, with all of your risk ratios, you're comparing that R00 in your denominator. And to the right of that, it's always that -1. So really, you're just looking at the A2 divided by N2. And to get a risk ratio, you're dividing that by the same number that you used for your comparison of your joint effects, which is the A4 over N4. So you're looking at the risk of just the exposure divided by the risk of neither, and subtracting out the underlying risk of 1. And then you're going to add to that the excess risk related to the effect modifier. So here what you're looking at is just the yes condition of the effect modifier and those who were not bullied. So for example, the urban kids who were not bullied, or the third column, the A3 number divided by N3, and divide that over your risk that you've already calculated from the R00, the non-exposed, non-effect modifier kids. So in other words, the kids who were not bullied and who were not urban, the rural not bullied kids, the A4 over N4. And so to get that excess risk of the exposure of the effect modifier only, you're looking at the R01 divided by R00 condition in your table, and then subtracting out the 1. So when you see this all in a row, what you can see is the excess risk is the final column I've added to this table, which is to say you can look at that by looking at RR11, so the risk ratio for both together, and that is calculated by A1 divided by N1, and then that divided by A4 over N4. And subtract that out by 1, you have the excess risk of the joint conditions together, the effect modifier and the exposure together. You're comparing that then to the formula of the risk ratio of just the exposure. So that's A2 divided by N2, and taking that and divide it over the risk of the 0,0 condition, which you've already calculated, and that's the denominator in every one of these formulas. So what is the risk ratio of the exposure only? That's A2 divided by N2. Divide that over A4 divided by N4, and then you get your risk ratio and subtract out 1. The final thing to look for is the measurement for just the effect modifier. So that is, in the example of urban, you're looking at the urban kids who were not bullied. They don't have the exposure. And that's A3 divided by N3, and you take that over the same reference group you've been using for the others to get your risk ratio, which is A4 divided by N4. Then you have your risk ratio related to just the effect modifier, and you subtract 1 just to get the excess risk. Okay, so imagine you filled this table in, and if you're still not quite sure how to do that, part 2 will go through how you take your stratified 2x2 tables and fill in the numbers here to get the formulas all laid out. But ultimately, once you have the information, you can fill in the formula and answer the question, is the excess risk of both together, the risk ratio 1, 1 minus 1, is that greater than, less than, or equal to the adding the excess risk of just the exposure and the effect modifier? So when you come to that answer, the question will be, well, what does it mean when it's greater than, less than, or equal to? If it's greater than additive, that means that the risk is amplified, so that when the exposure and the effect modifier occur together, the risks are beyond what would be expected, greater than what would be expected, or amplified over what would be expected if the two occurred separately. If the result is less than, it's the opposite. It means that it's not amplified, there's an antagonistic relationship. They're working against each other. So the risks, the excess risk when they both occur together are much less than, or a little bit less than, what you would expect if they occurred separately. If the result is that the excess risk of both together is exactly equal to the excess risk of each one separately, it means there is no effect modification, that the two are not interacting in any way, and it means that third causal pi does not exist. So if you're still not sure how to calculate this using your own 2x2 tables, take a look at the second set of PowerPoint slides, also in the YouTube playlist, and that should explain how you can fill the details of this table in as you work on your calculations. And I do that using an example from my own results, using the example of male-female, which is why I focused here on looking at urban versus rural, so you have also an example male-female in the second set of slides. Okay, have a wonderful Thanksgiving holiday. I'll see you when I get back. Thanks a lot. Bye.